The European Space Agency has been waiting for its turn. And finally, its moment has come to show the world that Europe is a challenger in the race to win space. The Ariane 6, their new rocket, is on its way to its maiden flight this year, 2024. But here's the thing. Some people are saying it's too little, too late. They think Europe's missed the boat on reusable rockets and that Ariane 6 is just a desperate attempt to play catch-up with the likes of SpaceX. But hold up. Before you go writing off Ariane 6 as a lost cause, hear me out, because I'm here to tell you that this rocket isn't just Europe's last hope. It's a game changer in its own right. Ariane 6 isn't just about competing with SpaceX. It's about ensuring Europe's sovereignty in space and protecting its strategic interests. Some of you might be skeptical. After all, Ariane 6 has faced its fair share of setbacks and delays. But that's just the nature of the beast when it comes to cutting-edge technology. And trust me, the engineers at ESA and Ariane Group haven't been twiddling their thumbs. They've been working around the clock to make sure Ariane 6 is ready to take on the challenges of the new space race. So buckle up, spacers. This is your specialist, the space technician, and we're about to embark on a journey through the ups and downs of Ariane 6's development. We'll explore the technical details that make this rocket a marvel of engineering, the political hurdles that have threatened to derail the project, and the strategic importance of Ariane 6 for Europe's future in space. All right, it's time to find out why Ariane 6 isn't just Europe's last hope. It's the rocket that will save the continent's space ambitions. Let's go! Remember, strapping in is optional, but recommended. Ariane 6 is the European Space Agency's answer to the growing competition in the commercial space market. It's a modular, heavy-lifting launcher that comes in two flavors, the Ariane 62 and the beefier Ariane 64. The P120C boosters are the workhorses of the Ariane 6 rocket, providing the majority of the thrust needed to escape Earth's gravity. Each booster measures a whopping 13.5 meters or 44.3 feet in height and 3.4 meters or 11.2 feet in diameter, making them one of the largest monolithic carbon fiber solid rocket motor casings ever built. Now, let's talk about the propellant. The P120C boosters use a mix of aluminum powder fuel and ammonium perchlorate oxidizer, which is shaped into a solid grain. This grain is carefully engineered to provide a specific thrust profile, optimizing performance throughout the booster's burn time. When ignited, each P120C booster generates a maximum thrust of 4,500 kilonewtons or 1,012,000 pound force at sea level. That's like having the combined power of over 1,000 family cars pushing the rocket off the launch pad. This thrust is maintained for a duration of 130 seconds, propelling the Ariane 6 to supersonic speeds. The P120C boosters aren't just powerful, they're also efficient. The nozzle of each booster is equipped with a movable joint that allows it to pivot up to 6.5 degrees. This gimbaling capacity enables the boosters to steer the rocket during the initial phase of flight, optimizing the trajectory and minimizing aerodynamic stress on the vehicle. Now let's talk about how these boosters are configured on the Ariane 6. The Ariane 62, the smaller of the two variants, uses two P120C boosters strapped to the main core stage. This configuration provides a total liftoff thrust of around 10,300 kilonewtons or 2,320,000 pound force, which is enough to send up to 10,300 kilograms or 22,700 pounds of payload to low Earth orbit, or 4,500 kilograms, 9,900 pounds, to geostationary transfer orbit, also known as GTO. But what if you need even more power? That's where the Ariane 64 comes in. This behemoth of a rocket uses 4 P120C boosters, arranged in a crosswise pattern around the main core stage. With a total liftoff thrust of approximately 20,600 kilonewtons or 4.63 million pound force. The Ariane 64 can carry up to 20,600 kilograms or 45,400 pounds to LEO, or 11,500 kilograms, 25,400 pounds to GTO. That's the equivalent of launching 2 fully loaded school buses into space. The P-120C boosters aren't just used on the Ariane 6 though. They're also employed as the first stage of the Vega-C rocket, a smaller launcher designed for lighter payloads. This commonality in booster design helps reduce production costs and streamline manufacturing processes, making the Ariane 6 and Vega-C more cost-effective and efficient. Let's take a closer look at the innovative design of the Ariane 6 rocket and explore the cutting-edge technology behind its liquid fuel core stages, engines, and payload capabilities. First, let's talk about the heart of the rocket, the Vulcan 2.1 engine. This marvel of engineering is an upgraded version of the proven Vulcan 2 engine, which powered the Ariane 5 rocket for over 2 decades. The Vulcan 2.1 is a liquid-fueled engine that burns a mixture of liquid hydrogen, LH2, and liquid oxygen, LOX, to generate an impressive 1,390 kilonewtons or 312,000 pound force of thrust at sea level. But what makes the Vulcan 2.1 truly special is its efficiency. The engine employs a gas generator cycle, which means a small portion of the propellant is burned in a separate chamber to drive the turbopumps that feed the main combustion chamber. This design allows for a more compact and lightweight engine, while still delivering high performance. The Vulcan 2.1 also features an optimized nozzle design, with a high expansion ratio of 58:1. This means the nozzle is carefully shaped to maximize the efficiency of the exhaust gas as it expands and accelerates out of the engine. The result is a specific impulse, a measure of engine efficiency, of 433 seconds at vacuum, making the Vulcan 2.1 one of the most efficient liquid rocket engines in its class. Now, let's move on to the upper stage and its Vinci engine. This is where the Ariane 6 really shines in terms of flexibility and multi-mission capability. The Vinci is a highly versatile engine that can be reignited up to 4 times during a single mission. This allows the Ariane 6 to deploy payloads into different orbits, adapting to specific needs of each customer. The Vinci engine uses the same LH2-LOX propellant combination as the Vulcan 2.1, but with a twist. It employs an expander cycle where the cryogenic LH2 fuel is used to cool the engine's combustion chamber and nozzle before being injected and burned. This design results in a simpler, more reliable engine with fewer components while still delivering a high specific impulse of 465 seconds in vacuum. But the Vinci's real party trick is its multiple ignition capability. By controlling the flow of propellants and using a special ignition system, the engine can be shut down and restarted several times during a mission. This allows the upper stage to coast between engine burns, conserving propellants and enabling complex orbital maneuvers. So, what does this mean for payloads? Well, the Ariane 6 can carry a wide variety of satellites, from heavy telecommunication spacecraft to smaller Earth observation and scientific missions. The rocket's payload fairing, which protects satellites during launch, comes in 2 sizes, a 12.7-meter, 41.7-foot long version for single large payloads, and a 17-meter or 55.8-foot long version for dual or multiple payloads. But here's where it gets really interesting. The Ariane 6 also has a unique feature called the payload adapter, which allows smaller satellites weighing under 200 kilograms or 440 pounds to piggyback on the main mission. These secondary payloads, often called rideshare or hitchhiker satellites, can be deployed into different orbits using the Vinci engine's multiple ignition capability. This opens up a whole new world of possibilities for small satellite operators, universities, and research institutions. By sharing the cost of a launch with the main payload customer, these smaller players can get their satellites into orbit at a fraction of the cost of a dedicated launch. It's a win-win situation that makes space more accessible and affordable for everyone. Now, I know what you're thinking. Space technician, this all sounds amazing. But what about the competition? Well, my friends, let me tell you, when it comes to the commercial launch market, there's no denying that SpaceX has been a major disruptor. Their Falcon 9 rocket, with its reusable first stage, has revolutionized the industry by significantly reducing launch costs. By landing and reusing the first stage booster, SpaceX can offer launch prices that are hard to beat, putting pressure on traditional launch providers like Ariane Space. But here's the thing. While the price is certainly an important factor, it's not the only consideration for satellite operators. Reliability, schedule assurance, and the ability to tailor launch services to specific mission requirements also play a crucial role. And this is where Ariane 6 really shines. You see, Ariane 6 is building upon the heritage of the Ariane 5 rocket, which has an enviable track record of 96 consecutive successful launches. This reliability is not just a point of pride. It's a major selling point for satellite operators who have hundreds of millions or even billions of dollars riding on each launch. They need to know that their precious payloads will reach orbit safely and on time. Moreover, Ariane 6 is designed with flexibility in mind, with its two variants, Ariane 62 and Ariane 64, and the ability to carry single or multiple payloads. The rocket can be tailored to the specific needs of each customer. This is particularly important for government and institutional missions, which often have unique requirements that may not be well served by a one-size-fits-all approach. But beyond the technical capabilities of the rocket, Ariane 6 also represents a strategic asset for Europe. By ensuring independent access to space, the rocket helps safeguard Europe's autonomy and sovereignty in an increasingly competitive and geopolitically complex environment. Think about it. If Europe were to rely solely on foreign launch providers, it would be vulnerable to potential disruptions or political pressures. What if a foreign government suddenly decided to restrict access to their launch services, or to prioritize their own national interests over those of Europe? With Ariane 6, Europe has a reliable and capable launch vehicle that it can count on to meet its space needs, regardless of external factors. And this strategic importance is not lost on key players in the space industry. Take the example of Amazon's Kuiper satellite constellation. This massive project, which aims to provide global broadband internet access, will require dozens of launches over the coming years to deploy its thousands of satellites. When it came time to choose a launch provider, Amazon founder Jeff Bezos made a surprising decision. He selected Ariane 6 over SpaceX for 18 of the constellation's launches. This was a major coup for Ariane Space and a testament to the confidence that industry leaders have in the Ariane 6 rocket. But why would Bezos choose Ariane 6 over SpaceX, given the latter's lower launch prices? Well, there are a few factors at play. First, Ariane 6 offers a level of schedule assurance and reliability that is hard to match. With such a large and complex project, Amazon needs to know that its satellites will be launched on time and with a high degree of success. Second, by spreading its launches across multiple providers, including Ariane 6, Blue Origin's New Glenn rocket, and United Launch Alliance's Vulcan Centaur, Amazon is reducing its risk and ensuring a degree of redundancy in case of any issues with a particular launch vehicle. Finally, there's the strategic angle. By supporting Ariane 6, Amazon is not only diversifying its launch options, but also helping to strengthen the European space industry. This could pay dividends down the line as Amazon seeks to navigate the complex regulatory and political landscape surrounding its Kuiper constellation. So, While Ariane 6 may not be able to compete with SpaceX on price alone, it offers a unique value proposition that combines reliability, flexibility, and strategic importance. As Europe looks to secure its place in the new space race, Ariane 6 will undoubtedly play a crucial role in ensuring the continent's access to space and protecting its interests in an increasingly competitive environment. But the development of Ariane 6 has been a complex and ambitious undertaking, involving the coordination of multiple countries, space agencies, and industrial partners. As with any large-scale engineering project, there have been bumps along the road. One of the biggest challenges has been the political landscape, with so many stakeholders involved, each with their own interests and priorities. Finding consensus and maintaining momentum has not always been easy. Disputes over funding, workshare, and technical specifications have at times threatened to derail the project. For example, in 2018, a disagreement between France and Germany over the use of a more advanced and expensive upper stage for Ariane 6 led to tensions and delays. France, which had originally pushed for the upgraded upper stage, eventually agreed to stick with the baseline Vinci Engine design in order to keep the project on track and maintain unity among the partner countries. Technical hurdles have also played a role in the delays. Developing a new rocket is an enormously complex undertaking, requiring advanced materials, precise manufacturing techniques, and rigorous testing to ensure reliability and performance. The Ariane 6 team has had to overcome numerous engineering challenges along the way. One such challenge has been the development of the P-120C solid rocket motor, which powers both the Ariane 6 and Vega C rockets. The motor, which is the largest monolithic carbon fiber solid rocket booster ever built, required extensive testing to validate its design and performance. In 2018, during a test firing, an anomaly occurred that forced engineers to revisit the motor's insulation and nozzle design. While the issue was ultimately resolved, it contributed to the overall delays of the program. However, despite these setbacks, ESA and its partners have remained committed to seeing Ariane 6 through to completion. In recent months, significant progress has been made, with the successful completion of several key tests. In October 2021, the Ariane 6 core stage underwent a successful hot fire test, validating the performance of the Vulcan 2.1 engine and the stage's propulsion system. This was followed in early 2022 by the successful static fire test of a fully assembled Ariane 6 rocket, marking a major milestone in the program. With these crucial tests now complete, Ariane 6 is on track for its maiden flight in the summer of 2024. This inaugural launch will not only mark the beginning of a new era for European spaceflight, but will also serve as a powerful demonstration of Europe's resilience and determination in the face of adversity. But the story doesn't end there. Even as Ariane 6 prepares to take flight, European space agencies and industry partners are already looking ahead to the next generation of launch vehicles. One such project is Ariane Next, a proposed successor to Ariane 6 that would incorporate reusable rocket technology. The goal is to develop a partially or fully reusable first stage, similar to SpaceX's Falcon 9, in order to reduce launch costs and increase the competitiveness of European launch services. To support this effort, ESA has initiated the SALTO, Reusable Strategic Space Launcher Technologies and Operations project. SALTO aims to develop and demonstrate key technologies for reusable launchers, such as advanced materials, propulsion systems, and recovery techniques. One of the key components of SALTO is the Prometheus engine, a low-cost reusable methane-oxygen engine that could power the first stage of future European rockets. Prometheus is designed to be highly versatile, with the ability to throttle its thrust and reignite multiple times, making it well-suited for reusable launch vehicle applications. In addition to Prometheus, SALTO is also investigating advanced manufacturing techniques, such as 3D printing, to reduce the cost and complexity of rocket components. By leveraging these technologies, Europe hopes to create a new generation of launch vehicles that are more affordable, sustainable, and responsive to the evolving needs of the space market. These future projects underscore Europe's commitment to remain at the forefront of the global space industry by learning from the challenges faced during Ariane 6's development and investing in cutting-edge technologies. ESA and its partners are positioning themselves to thrive in an increasingly competitive and dynamic space landscape. As Ariane 6 prepares to take its place as Europe's workhorse launcher, it is clear that the rocket represents not just a technological achievement, but also a symbol of European unity, perseverance, and innovation. With the lessons learned from Ariane 6 and the exciting developments on the horizon, Europe is poised to play a leading role in the future of spaceflight. So, there you have it, spacers. Ariane 6 isn't just a rocket, it's a symbol of Europe's determination to reach the stars. With its powerful engines, flexible design, and strategic importance, Ariane 6 is set to be the rocket that saves Europe's space dreams and autonomy. As always, thanks for joining me on this journey through the cosmos. Don't forget to like, subscribe, and ring that bell for more out-of-this-world content. This is the Space Technician, signing off for now. And I'll see you, Space Cowboys, in the next one.